Hi, and welcome to Venus. In this video we're going to talk all about Venus and all of the things that are going on with our sister planet. Venus is often said to be the sister planet to Earth because it's comparable in size, it's comparable in mass, and it's comparable in location to our own planet Earth. So let's take a look at what makes Venus different than Earth, because it is very different, even though similar in some ways. So Venus is named after the goddess Aphrodite, the goddess of love and beauty. I think it makes sense. Venus looks really beautiful up in the night sky if you happen to catch a glimpse of Venus up there. Venus, like I said, is pretty comparable to our Earth. So let's take a look at those numbers. In terms of radius, it's 95% of the radius of our own Earth. So pretty close to being the same. Mass, again, 82% of Earth's mass. So pretty similar. In terms of distance, it's 79% of the distance from the Sun to where we are. Again, that's pretty similar. But that's kind of where the similarities stop for the most part, right? It's made out of the same stuff, of course. But notice that temperature there. It's really, really hot on Venus. Now, that's a hot temperature in Kelvin. It's even hotter in Fahrenheit, about 900 degrees Fahrenheit, right? Ridiculously hot. So we need to take a look at what's making it so hot. Why is Venus so hot? Let's give that a go. All right, so first of all, Venus does something really odd as it goes around the Sun. What happened to Venus is not exactly certain, but it seems like Venus has gotten flipped over. Okay, so remember Earth is at that 23-degree tilt, 23.5-degree tilt. Venus is almost entirely flipped all the way over, right, upside down. This means that as Venus goes around the Sun, it actually spins the opposite way of the rest of the planets. Okay, so most of the rest of the planets spin what we call prograde, right, the regular way around. Venus, on the other hand, spins backwards. Okay, so most planets go around the Sun counterclockwise. They also spin counterclockwise. Venus goes around counterclockwise, that's fine, but it actually spins clockwise. It's spinning opposite to the way it orbits. Again, not really sure why that is, but it is the way Venus is moving in the sky. Venus also spins really slowly. Okay, the rotation rate of Venus is actually longer than its orbital rate, right? So it takes longer to spin on its axis backwards than it does to actually orbit the Sun, right? So 243 days for that rotation, 224 for the time that it goes around the Sun. Kind of an interesting thing, right? Really slow rotation there for Venus. So retrograde rotation means that it rotates in an opposite direction compared to the rest of the planets. It does also rotate much more slowly, but the retrograde part is what we're looking for here, right? In the opposite direction to the rest of the planets. Right? Remember, retro is backwards. Let's talk about that atmosphere. Okay, so we noticed that Venus was really, really hot, right? 900 degrees Fahrenheit. That's because of the atmosphere that's on Venus. Venus is about the same size as the Earth, and with that large size, Venus is able to hold on to a lot of atmosphere. Unfortunately for Venus, that atmosphere is almost entirely carbon dioxide. Okay, carbon dioxide makes the news all the time here for our greenhouse effect. Now on Earth, we have 0.004% carbon dioxide in our atmosphere, right? So not even 1%, right? A tiny little percent. On Venus, we're talking 96–95% carbon dioxide. Okay, that's a lot of carbon dioxide. Not only that, but there's just a lot of atmosphere. Okay, so it's mostly carbon dioxide, but then there's a whole lot of it. It's just a ton of carbon dioxide up there. On Venus's surface, the air pressure is about 92 times Earth's atmospheric pressure. This is equivalent to being 900 meters below the ocean surface here on Earth. 900 meters. Okay, remember a meter is about 3 feet. Okay, so we're way underwater there. Okay, what is that? How about half a mile underwater? Okay. This means that if we were to send, let's say, a rover or manned missions to Venus, it's got to be able to contend with not just that high temperature, but it's got to be able to deal with that extreme atmospheric pressure. That kind of atmospheric pressure would crush something, right? If you were to take some sort of sea craft down to half a mile below the ocean's surface, you'd have to have a pretty sturdy submarine to be able to cope with that sort of pressure. Same thing would be true out there on Venus, right? So really hot because of that greenhouse effect and all that carbon dioxide, and just a crushing pressure with that 92 times Earth's atmospheric pressure. So if you wondered why we don't send rovers to Venus, there you go. So if we look at the atmosphere of Venus, there actually are some cloud layers on Venus, which is nice, right? Clouds are nice. But these clouds aren't so nice. Okay? These clouds are actually made out of, some of them, acids, right? Lovely acid clouds. Okay, so when I talk about acids, I don't mean like, you know, maybe like a citric acid, right? Something that's not that bad. We're talking the really strong acids, things like hydrochloric and hydrofluoric acid. Right? When they're doing glass etching, they use hydrofluoric acid. So this is wicked stuff, right? Just really hot, acidic. The winds blow really hard, right? 240 kilometers an hour is really fast. Okay, so you've got high winds, high pressure, acid clouds, and it's really hot. There's just a lot of problems with sending something to Venus. Some surface features on Venus that are interesting, and you may wonder, well, wait a second, we've got all these clouds. How are we figuring out what the surface looks like? Well, we've actually used radar mapping. Right? Radar is the same stuff that they use on airplanes to try and track where airplanes are. This radar, it has been bounced from a spacecraft down to the surface of Venus and then bounces back up to the spacecraft. They can use the time lag of that trip to figure out what the surface heights are. Okay, so this is a nice radar mapping of what we have going on Venus's surface. And so if you could see underneath the clouds like we can here, you can see that it looks like a terrestrial planet. We've got that rock surface there. Unfortunately, they've colored this with a blue tinge. Don't think that that's water. This is just a map of elevation. Okay, so those blue areas are lowland areas. And then we've got some highland regions. Those are the red and the yellows there. Okay, so think of it as a topographic relief map, right? Blue is low, the reds, the yellows are much taller. Okay, so on Venus, we're seeing lots of smooth lowland regions, but it's also got some big surface features. Maxwell Monts in particular is 50% higher than Mount Everest even. Venus does have craters. About 1,000 impact craters are on Venus's surface. That means the surface is not very old. Okay, 1,000 craters is not a lot. It's more than we have here on Earth, but not a lot, so not very old surface. Now, we know there's no water on the surface. It does have that thick, dense atmosphere that helps protect it from some impacts, but there's no erosion going on there. The craters do appear nice and sharp and fresh. Again, there's no erosion to round anything out. Okay. The Soviets were really great about exploring Venus. They sent a number of missions out there to go check out Venus. These were the first actual landings on another planet. So this is the Venera program here. Right? So here's their probe here, just an awesome looking contraption, right? You can see it here in their kind of mock-up of how it's landing here on the surface of Venus, right? It parachutes in through that really thick atmosphere, which is great, right? Really slowing it down. Lands on the surface, and then it's going to radio back to a satellite and then back up to Earth. Really ambitious though, right? Check out the year on that, 1961, when they tried to go for their first landing. A very ambitious program that they had. They were successful. Not every mission that they sent was successful, but Venera 9 did give out the first photos ever of Venus. Here they are. Looks pretty terrestrial, doesn't it? It's almost a little disappointing how ordinary it looks. It's not the greatest photography, but you can see rocks, gray, pretty standard, honestly, for most of our planets out there. Some of the other great pictures are from the Venera 13. When they take pictures of Venus, it often looks this orange color like you're seeing in this picture here. That orange color is because of the atmosphere. The atmospheric haze makes it look like you're wearing orange colored sunglasses, right? Everything just kind of looks orange. It's not actually orange. Okay, so what they did on Venera 13 is this is the footbed of the spacecraft here with the little triangles. And so what they did is they painted this with some colored stripes so that when they got those pictures back, they could color correct out this orange, right? Color correct back for those stripes that are there. If you're wondering about this funny shaped rock here, that's actually the camera lens. They had a little lens cover on it, and when it popped off, it ended up falling right in the picture. So let's take a look at what that looks like color corrected. Again, kind of a boring gray. Right? It's a little disappointing. I mean, I feel a little disappointed about it, right? So don't be fooled when they show you Venus in that kind of orange color like I had in the very first slide. It's not really orange. That's an artifact of the atmosphere. We have been back to Venus, but we've never sent a lander there. We've sent other exploration vehicles, things that orbit Venus. The last thing we sent was the Magellan spacecraft and got into orbit around Venus in 1990 and stayed in orbit for about 4 years. We used this probe to get really good radar data of what was going on the surface of Venus, right? Really mapping in detail the surface features that are there to try and understand the geology of Venus, right? Look for things like shield volcanoes, look for things like plate tectonics, that sort of thing. This also worked to try and map the gravity field of Venus, hoping to get an inside look at what was going on inside of Venus. What's it made out of inside of there? And we can look at the gravity data to try and get a handle on, is it liquid on the inside, is it solid on the inside, and that sort of thing. So let's take a look at some of the things that Magellan found. We found some lava flows. And you can see that pointed out by the little arrows on this photograph, right? A nice little flow of lava there. There it is. We've also got some corona. Okay, so corona are kind of upside down volcanoes, right? They go in instead of going out, kind of like a depression. This is one of those corona there. Right? Again, we're talking about volcanic activity. Is it active volcanic activity or is it volcanic activity in the past tense? Still not entirely clear what the story is there. There are, of course, pancake domes. Okay, remember our pancake domes, those are going to happen with the shield volcanoes. Okay, so you can even see some of those are in here, right? We've got some pancake domes in there as well with the corona. Again, here's another nice lava flow. Some of these lava flows actually are, they were just like subsurface. And then after that lava drains out of that subsurface tube, the top of the tube will then collapse in. We see this also on the moon. The moon has some features like that called sinuous riles. Here you're seeing that kind of thing here on Venus.